Welcome to Video 6, Progress Monitoring for Solving Basic Problems. In this video, we are going to focus on using progress monitoring to ensure that math instruction builds on what each child knows as it relates to solving basic problems. Progress monitoring involves two key instructional practices. Gather information on a child's existing knowledge and skills relative to a developmental progression, and tailor instruction to children's learning needs and continuously monitor progress. Let's begin by taking a look at the number and operations developmental progression. The progression tells us that after children can reliably and accurately subitize small quantities, they are ready for nonverbal addition and subtraction. For example, if you show a young child 2 blocks before hiding them under a box, then show 1 more block before also hiding it under the box, a child can produce 3 blocks to match what's hidden under the box. To be able to do this, children need to be able to hold representations of those small quantities in their head and operate on them. After children can use meaningful counting to determine which of 2 collections has more, they are ready to use counting to solve basic arithmetic problems, usually using objects or fingers. Some children will use a direct modeling strategy to solve basic problems. That is, they act out the problem on their fingers or by using objects. Consider the following problem. Milo has 3 cookies, and his mother gives him 2 more cookies. How many cookies does he have now? Some children will count and hold up 3 fingers on one hand, then count and hold up 2 fingers on the other hand, and then count all of their fingers. This is the counting all strategy you learned about in week 1. Some children will use a more advanced counting strategy that includes a shortcut so they don't have to do all that counting. For example, when trying to determine how many cookies Milo has, a child might immediately hold up 3 fingers on one hand and say 3, then hold up a finger on their other hand and say 4, and then hold up a second finger and say 5. Milo has 5 cookies. This strategy is called counting on. How well children can use these counting strategies is dependent on their meaningful counting skills. Children need to be able to recite the count sequence in the correct order, accurately count with tagging, and understand cardinal values. Children are ready to use counting on and other advanced strategies when they can begin counting anywhere in the count sequence. That is, they don't have to begin counting at 1. Now, let's look at some examples of children solving basic addition and subtraction problems. The problems are presented in 2 contexts. In the nonverbal hidden result problems, a child is shown the transformation of a set, but the result is out of view and uncountable. The task is nonverbal because the child doesn't need to know number names in order to solve the problem. In the verbal story problems, a child is presented with a brief word problem and given access to different tools to use to solve the problem. As you watch each clip, take notes in your learning journal to record what you notice about the children's problem-solving skills, including the strategies and tools each child uses, using the excerpted sections of the progress monitoring logbook. After you watch each clip, you'll be asked to indicate which skills you did and didn't observe, and then decide on next steps for the child using the developmental progressions. Let's watch the first video of a child engaged in a hidden results activity.
We're going to play a game called How Many Are Hiding in the House. So I'm going to take my bears and I'm going to put some bears inside the house and we'll see what happens, okay? And then you can watch and then you're going to show me. I'm going to give you a mat just like this. I'll put it here with some bears and then you can make your mat match my mat. Watch me. Watch me. I wonder how many bears are hiding in my house. Can you show me? can you show me on your mat what you showed me on your fingers? Can you tell? Two bears. You want to show me on your mat what that looks like? You can use the bears and show me so your mat can match my mat. And you can show me what's inside my house. You ready? Look at that. They're the same. Two bears and two bears. All right. You gotta watch. Oops. Turn them around. Watch me. Watch me. I wonder how many bears are hiding in my house. You want to show me on the mat with the bears so your mat can match my mat? How many bears are hiding in the house now? You want to show me on the mat? I see your fingers. You can use the bears and show me so your mat will look just like my mat. You done? Let's see. You have two bears and I have two bears. All right, you ready? Gotta watch me. How many bears are hiding in the house now? I think you're showing me on your hand. Oops. Do you want to show me on the mat? You can use the bears and see if your mat can match my mat. So we can see how many bears are hiding in the house. Are you done? Let's see. I have 5 bears and you have 5 bears. Here you go. Watch me. Are you watching? Are you watching? Watch me. How many bears are hiding in my house now? Can you show me on your mat? Can you make your mat match my mat? So we can see what you think is inside the house? Are you done? You done? Okay, let's see. You have 4 bears and I have 2 bears.
What did you notice about Aurora's problem-solving skills? How would you describe the strategies and tools she used to solve the problems? Pause this video and take a minute to summarize your observation in the space provided in the Teacher Learning Journal. Let's take a look at how you could have completed the logbook. Aurora mentally, or non-verbally, combines and separates small subitizable quantities of 3 or less with relative ease. She successfully solved 1 + 1 and 3 - 1 mentally by showing the result on her fingers. For 3 + 2, she appeared to show 4 fingers at first, but then correctly put out 5 bears on the mat. She had difficulty solving operations with quantities larger than 3. For 4 - 2, she put out 4 bears on her mat. Aurora's nonverbal addition and subtraction skills fall within the 3rd band on the developmental progression. Given that Aurora is 5 years old, her skills are within range of other children her age. Based on your observation and the number and operations and solving basic problems developmental progressions, what should be the teacher's next step with Aurora? Pause the video and jot down your thinking in your Teacher Learning Journal. Aurora's teacher may want to continue providing Aurora with experiences solving problems with sums and differences within the quantity of 5. Aurora's teacher may also want to introduce and encourage the use of direct modeling strategies and tools to solve basic addition and subtraction problems with small, subitizable quantities at first. Now, let's watch a video of a different child solving verbal word problems.
For this game, Emily, what we're going to do is I'm going to tell some stories. So we're just going to listen first, okay? And then I'm going to ask you to help me solve a problem in the story. And the problem is how many bears, okay? And to solve the problem, to figure out how many, you can use your fingers. You can use anything that you have here on the table. All right, are you ready? Okay. There were 2 bears at the playground. Okay. Then 1 more bear came to the playground. How many bears are at the playground now? And I can read it again. Do you want me to read it again, or do you want to just try it? Let's see. Okay. There were 3 bears at the playground. 2 more bears came. How many bears are at the playground now? 1 bear is at the playground?
Yeah.
Do you want to use your fingers to show, or do you want to use any of the bears? You can use the bears if you want. Or the crayons, whatever you want to figure out. You can draw on the paper. What would you like to do? You want to use the bears? Okay. Do you want me to start the story again so you can hear it? Okay. You ready? There were 3 bears at the playground. Can you show 3 bears at the playground? Then 2 more bears came to the playground. How many bears are at the playground now? I want to move this over.
5.
Okay. There were 7 bears at the playground.
Look at that color.
Then 2 more bears came. How many bears are at the playground now? You're done? Should I read it again so we can hear it? Okay. There were 7 bears at the playground. Then, do you have 7 bears? Do you want to see?
1, 2, 3, 4, 5, 6.
But there were 7 bears at the playground. Now, how many bears do you have there?
1, 2, 3, 4, 5, 6, 7.
Okay, so 7 bears were at the playground. Then 2 more bears came to the playground. Now how many bears are at the playground?
1, 2, 3, 4, 5, 6, 7, 8, 9.
So how many bears are at the playground?
9.
What did you notice about Emily's problem-solving skills? How would you describe the strategies and tools she used to solve the problems? Pause this video and take a minute to summarize your observation in the space provided in the Teacher Learning Journal. Let's take a look at how you could have completed the logbook. Emily appeared to use a combination of direct modeling and subitizing to solve 2 plus 1. She used subitizing to produce the sets of 2 and 1, then subitized the result, 3. Because both quantities and the sum were within her subitizable range, she didn't need to use counting. When it came to solving problems with slightly larger quantities, she needed prompting to use counting to solve the problem. With support, she used the counting all strategy with manipulatives to help her solve 3 plus 2 and 7 plus 2. Emily's counting-based problem-solving skills fall within the first band on the progression and are consistent with other 4-year-olds. Based on your observation and the number and operations and solving basic problems developmental progressions, what should be the teacher's next step with Emily? Pause the video and jot down your thinking in your teacher learning journal. Emily's teacher may want to encourage and reinforce Emily's use of counting to solve basic addition and subtraction problems. To help Emily see the usefulness of counting to solve problems, Emily's teacher may want to create opportunities to model how to solve authentic problems in the classroom by using counting. Now, let's watch another video of a different child solving verbal word problems.
I'm going to tell stories about bears again, Saul, okay? And when I tell you the story, I need your help to solve a problem. And the problem is how many bears are in the story, okay? Here's the first story. There were 2 bears at the playground. Then one more bear came. How many bears are at the playground now? And you can use anything and even your fingers if you want to figure out.
3.
3 bears were at the playground?
Yeah.
Okay. Are you ready for the next story? Okay. There were 3 bears at the playground. 2 more bears came. How many bears are at the playground now? 4 bears at the playground. Were you showing me on your fingers? Let's see, can you show me? I think we started with 3 bears. Can you show me 3 bears at the playground? 3 bears at the playground, and then you counting to make sure there's 3 bears. And then 2 more bears came to the playground. You want to show on your fingers 2 more? There's 3. 3 fingers and 2 more. You can use your other hand. Do you want to use your other hand if you want? So 3 bears at the playground, and then 2 more came. 2. Now how many bears are at the playground?
1, 2, 3, 4, 5.
So how many bears are at the playground?
5.
5 are at the playground now. There were 5 bears at the playground. 2 more bears came to the playground. Now how many bears are at the playground? So you can show me. 5 bears were at the playground. And when you have 5 bears, so when you have 5 bears at the playground, let me know, okay? Because that's how our story starts. There are 5 bears at the playground.
1, 2, 3.
Oh, what about the ones back here? Did you count all of the bears?
2, 3, 4, 5.
Oh, now.
1, 2, 3, 4. 1, 5.
Did you put 5 down? Are there 5 now? I saw you had more in your hand. You want to count to make sure we have 5 bears because there were 5 bears at the playground. We want to make sure there's only 5. Do you want to touch them so you have?
1, 2, 3, 4, 5.
Okay. And then 2 more bears came to the playground.
7.
How many bears are at the playground now?
7.
That's kind of fun to tell stories about bears, isn't it?
What did you notice about Saul's problem-solving skills? How would you describe the strategies and tools he used to solve the problems? Pause this video and take a minute to summarize your observation in the space provided in the Teacher Learning Journal. Let's take a look at how you could have completed the logbook. Saul appeared to use his knowledge of basic addition facts to solve 2 plus 1. He just knew the result was 3 and didn't need to model the problem or use counting. To solve 3 plus 2, he attempted to directly model the problem using his fingers, but came up with the wrong result. With some help, he was able to use the counting all strategy more effectively by representing each quantity on separate hands and then counting all his fingers to find the correct result. Saul struggled to solve 5 plus 2, but this is likely due in part to him being unfamiliar with 5 frames. He also demonstrated keeping track of errors while counting. Saul's counting-based problem-solving skills fall within the first band on the progression. His basic addition and subtraction fact recall fall within the first band on the progression. Given that Saul is 4 years old, his performance is consistent with other children his age in both skill domains. Based on your observation and the number and operations in solving basic problems developmental progressions, what should be the teacher's next step with Saul? Pause the video and jot down your thinking in your teacher learning journal. Saul needs more practice using direct modeling strategies to solve basic addition and subtraction problems. Saul's teacher should encourage Saul's instinct to use his fingers or manipulatives to solve problems, and then gradually introduce other problem-solving tools such as 5 and 10 frames. Now, you're ready to begin progress monitoring for solving basic problems in your classroom. Remember to use the progress monitoring logbook to record student progress on each key skill and indicator, making notes of children's demonstration of skills not only during structured activities, but also during unstructured times and in all areas of the classroom. Children are putting their math skills to work everywhere. Children can engage in basic problem-solving activities even as they are developing their counting and magnitude comparison skills. Problem-solving activities help children learn and strengthen these skills. As you plan for math activities in your classroom, frequently consult your progress monitoring data to help you select activities, group children, and tailor instruction for individual children. Each activity in this module has a section on how to use your progress monitoring data to accommodate the different skill levels children bring to the activity.